Hello everyone, welcome back to the online class of physics class 9. And the last video we were learning about the first law of motion. So we got to know that the first law of motion, the idea was given by Galileo and it was further improved by Newton, after which Sir Isaac Newton gave the definition for the first law of motion, according to which it was stated that for every means if any object is in a state of motion or rest, the object remains in that motion until and unless some external force acts upon it. That means if an object is at motion, it will try to be in motion. If an object is at rest, then it will be continue to be at rest until and unless some extra force or outer force acts upon the object to make the object move or to make the object stop. That means if an object is moving, then to make the object stop we have to put some force, and if the object is at rest, and to make it move we have to give some or provide some force. That was the first law of motion, and the first law of motion was also known as the law of inertia. And in the last video I told you that inertia is the state of an object, means either the object may be moving or the object may be at rest. That is known as inertia. And inertia, I told, depends on mass. The more heavier the object, the more external force or outer force, unbalanced force may be required or will be required. Like for example, if a stone is lying at a place and we need to move the stone. So normally stones are heavy, and if it is a very big stone, so to make the stone move, we will need to apply force. If the stone is bigger, more force will be required. If the stone is small, then less force will be required to make it move. Further, some activities, or you can say some illustrations from real life examples can be taken. Like for example, every one of us might have traveled in vehicle. Every one of us has traveled in vehicle, either a car or a bus. So you might have experienced, like while traveling in steep turns, if the vehicle is going through turn roads, like if this is a car, any object or car for example is moving at this direction. This is the road, the car is moving at a certain direction on the road. Like for example, this is the road which is having a turn. Like this is the road having a turn, and a car is going in this direction. Then when the car is moving on the road in the particular direction and suddenly the car or the vehicle takes a turn, we feel like we'll be thrown out of the car. Like for example, if the car, for example, this is our car, it is going in this direction and suddenly the car takes a turn, then we feel like if the person is sitting inside, he will feel like he is thrown to the outside body or thrown towards the body of the car. We get a force like we are getting to the other side of the car or of the bus. Like this happens mostly in vehicles because the person which is moving in the vehicle, according to the body of the person, means for the person is moving along with the vehicle and he is moving at a particular direction with the vehicle. Now suddenly when the vehicle takes a turn, steep turn, what happens? The person's body is still, or the person's body still wants to be in that particular motion in which it was going, means it was going straight. But as the vehicle has taken the turn, the body wants to remain in this motion. So what happened? The person feels like he has been thrown to the other side of the vehicle or to the side of the vehicle. Like this is a bus, for example. A person is sitting here, means we are seeing from the upper side of the bus. This is the bus moving at the road. The person is sitting here. He is sitting here. When the bus is moving in this direction, the bus is moving in forward direction, the person is also moving in forward direction with the bus. But suddenly when the bus takes a turn, the structure of the bus, or we can say the body of the bus, takes the turn. But the person which is inside still have the force which makes him move forward. So the person gets a force of falling to the other side or to the body of the bus. We get a jerk like we are going to fall to the other side of the bus. This is an example of inertia, or the act of inertia, we can say. Secondly, any other example, like we can take the example of a tree. In a windy day, you might have seen then when the wind is blowing, leaves fall off the tree. Or for example, if a tree is still, it is still, small tree is there, still it's not moving, and suddenly you go and try to shake the tree or shake one of its branch. What happens? Leaves or fruits fall from the tree. So what happens when the tree, for example, this is the tree, this is a branch, and there are some leaves or fruits in the tree. So when the tree is as the tree is in rest, the branches are also at rest and the leaves are also not moving. Means everything is at rest. But when a person comes there and tries to shake the tree with a stick or something, he tries to shake the branch comes in rest. But the leaves attached to the branch or the fruits attached to the branch don't move. They still want to be in rest. So what happens? The branch comes in motion, but the leaves don't come in motion. So they break from the branch and fall down. Then you might have seen carom. So in carom, there are small coins, white and black coins with one red coin and a big striker. So when we strike the striker, means when we click or hit the striker goes and hits any other coin. After which either the striker moves, but there happens two things. For example, this is a carom board. These are the pockets, and there is any small coin here, and any person hits the striker. When force is applied to the striker moves and goes and hits the other coin. After hitting the other coin, this coin goes and falls into the pocket or goes any other direction. And also with it, the striker either stops or striker also moves to other direction. So what happens in this? In the beginning, the striker was at rest. We apply force by hitting the striker. Then that force makes the striker move, and the striker goes and hits another coin. Due to which the striker gets opposite force, means opposing force, due to which the striker moves or sometimes changes its direction. But due to the force applied from the striker to the other coin, that coin moves and goes to the pocket or goes to any direction we hit it. So these are some of the examples of inertia. And inertia mostly depends on mass. The more heavier the object, the more will be the inertia. And if the object is less heavier, then inertia will also be less. That means the force which will require to make the object move will also be less. If the object is having more mass, then we will need more force to make it move or to change its motion. If it is rest, it will move. If it is in motion, it will stop. And if the object is having less mass, then we will need less force to make it move or to change its state of inertia. So this much only for today. I suggest you to read page number 118, inertia and mass, and try to solve some of the in-text questions. Means you can try to solve the first question, in-text question. Thank you. Only this for today.